I'd like to go over the multiple choice section of the Unit 5 practice test, and I'll do that as a file, then I'll go back and do the FRQ section separately. So we start off with our statement questions, where we have to take each of these and say whether they are true or false. For the first one, in the reaction magnesium plus fluorine turns into magnesium fluoride, magnesium is reduced. So the idea, well, magnesium here is 0, and magnesium over here in its compound is 2+. So if it's going from 0 to 2+, that's not reduced, that's oxidized. So that is false. And the element is reduced when it gains electrons. So we say, okay, Leo the lion says Gur. And that means reduction occurs when it gains the electrons, so this is also false. So the first answer is false, false. Number 2, calcium sulfate is a precipitate if it is formed in a double replacement reaction. We have to look at the solubility rules. We see sulfates are usually soluble, but not with calcium, barium, strontium, and lead. So this is true. It is a precipitate. And because it is soluble in aqueous solution, no, that's wrong. Okay, that's a precipitate because it's insoluble. So that's a true false. When heated, magnesium oxide becomes magnesium and oxygen. This is false. And this is that question where when we are going to decompose something by heating, it turns into its elements. So that would turn into magnesium and it would turn into oxygen, not the ions. If we dissolved it in water, it would turn into those ions. But this statement is false. Magnesium oxide is an ionic compound. That is absolutely true. So this would be a false true. Okay, number 4. In a chemical reaction, the total mass of the chemicals before the reaction and after the reaction is equal. Okay, that's called the law of conservation of mass. Mass is equal before and after. Now, the number of atoms is also equal. The number of moles of chemicals, that's not always equal because that depends on how the atoms are grouped, but mass is definitely equal. Number 5, which of the following reactions results in a single product? Okay, something that turns into single products. We're talking about maybe a couple of things turning into one thing. Okay, that situation, that is a synthesis reaction. For all the others, we get 2 products. Number 6, coefficients that will balance this equation. Well, looking at this, I'd say, well, I kind of think I would start here at the CS2, because that gives me 2 sulfurs. And if I have 2 sulfurs, that means I'm going to have a 2 here. Now that means I'm going to have 2 times 2, 4 oxygens, which would give me a 4 over here. And that would be, I have 1 carbon here, and I have 4 carbons here, so I have 5 carbons, so I'll put a 5. So I want an answer that's 5214. There it is, answer D, 5214. Number 7, what's the coefficient in front of the oxygen when the equation is balanced? Okay, so we say, well, I think that I would start, I would start here with the hydrogens. There's 3 hydrogens there, and there's 2 hydrogens there, and that's the only place hydrogens are. So that's the tricky one. If I have a 3 and a 2, I'm going to use a 2 here and a 3 here to get those to balance. Now, that's my hydrogens balanced. Now let's say nitrogens. This is on here, I have 2 nitrogens because of the 2, so this has to be a 2. And now I have oxygens, and oxygen is always good to leave that last because that can be any number I want it to be. So this side I have 2 oxygens, here I have 3 oxygens, 5 oxygens, so this is going to be 5/2 O2. Now the problem says use the lowest whole number coefficient, so I'm going to have to double. So I'm going to have 4, and I'm going to have 5, turns into 4 and 6. So the question is, what's the coefficient in front of the oxygen? It would be 5. Okay, next page. On number 8, what's the coefficient for oxygen for the equation, the combustion of propane? So I've got to write my equation, C3H8. Got to mix it with oxygen. It's going to turn into CO2 and H2O. And I can see I have 3 carbons, so I'm going to get 3 CO2s, 8 hydrogens, 4 H2Os. So I have 3 times 2, that's 6. 4 times 1 is 4. 10 oxygen atoms, which would be 5 O2s. So the answer here is 5. Solutions of silver nitrate and calcium chloride are mixed in a precipitate forms. What is the correct formula of the precipitate? So there are two ideas here. If I mix together silver nitrate and calcium chloride, I'm going to get silver and chloride. And I have to say, well, I know that Ag is Ag plus and Cl is Cl minus. So one compound is AgCl2. No, I just said that wrong. One is AgCl, plus and minus 1. The other I have calcium and I have nitrate. Now I don't really even need to look that up because I know in my solubilities all nitrate compounds are soluble. So that cannot be the answer, that cannot be the answer. It has to be one of these two. And since it's Ag1 plus Cl1 minus, the answer is A, AgCl. Number 10. The following compounds are formed during double replacement reactions. Which one would be a precipitate? So again, this is using my solubility rules, and I'm going to do some elimination. I know that potassium compounds are always soluble. I know that acetate compounds, and I know ammonium compounds. That's the first rule on that sheet, and it's given to you on the test. So it has to be answer A, copper hydroxide. Number 11, which of the following would be a precipitate formed when these two chemicals are mixed? So again, we have barium and sulfate, we got potassium and chloride, and it's not going to be a potassium compound because all potassium compounds are soluble. So I know that that is not the answer. Okay, so I know it's not C, both of those. Okay, the question is barium sulfate a precipitate? And the answer is yes, it is, because we see on our solubility rules, sulfates are soluble except for calcium, barium, strontium, and lead. So this would be a precipitate. The answer is A. Number 12. When lead acetate and silver sulfate are mixed, when lead acetate and silver sulfate are combined, which of the is a spectator ion? Okay, to do this, we really need to kind of write out a reaction. And so we say, okay, so lead acetate, that is going to be soluble because acetate compounds are soluble. Okay, silver sulfate, we said sulfates are soluble except for calcium, barium, strontium, and lead, so silver sulfate would be soluble. So these two would all be soluble, and then they're going to combine to give us lead sulfate, PbSO4. And if we look on our thing, we say, okay, sulfates are soluble except for lead, CbS and P, so that one is a precipitate. So the other two ions could be our spectator ions, silver and acetate, unless they react, and they don't. So silver and acetate, because acetate compounds are soluble. So which of the following is spectator? Silver is a spectator. If acetate was a choice, that would be a spectator too. So the answer is A. Which of the following does not form a gas? Okay, well, we have to kind of think about these reactions. So zinc and hydrochloric acid, that is going to be a single replacement reaction forming hydrogen gas and zinc chloride. So that is not the answer. That makes a gas. K2SO3, HCl, those are going to change partners, double replacement. The H's and the SO3s are going to form H2SO3, which is one of the things that gases that form. That breaks up to give H2O liquid and SO2 gas. So that's not the answer. We're going to get SO2 gas. C, when we burn, we get CO2 gas and H2O. So the answer is D. All of these produce gases. So the first one for single replacement, second one by double replacement, third one by combustion. So lots of information in that question. Okay, 14. In the reaction above, which of the following represents the oxidation half-reaction? Okay, oxidation, the number goes up. Oxidation, the number goes up. So let's look at this. Nickel to nickel 2 plus, that's possible. Nickel 2 plus to nickel, so that's not the answer. Zinc to zinc 2 plus, zinc to zinc 2 plus. Okay, so any of those three could be the answer. Okay, when we oxidation, we say gain, reduce, oxidize, lose. So losing electrons is oxidation. That means electrons are going to be on the right side of the arrow. So that means this cannot be the answer. So which of these really is nickel turning into nickel plus, or is zinc turning into zinc 2 plus? And we can see zinc neutral is turning into zinc 2 plus. So this is the answer. The nickel this is a good equation, but it's not what's happening. You know, nickel is going from 2 plus to nickel 0, not the other way around. So that's why that's not the answer. Answer C. Which of the following represents the products when magnesium is placed in hydrochloric acid? Okay, this is similar to our ornament lab. So we have neutral magnesium and we have hydrochloric acid. So you can see that's going to be a single replacement reaction. We're going to get magnesium chloride, and since we know that magnesium is 2 plus, then we're going to get MgCl2, and we get hydrogen gas, and we'd have to balance like that. So which of the following represents the products? We're looking for MgCl2 and H2. MgCl2, there it is. Okay, so that's answer B. For 16, strontium and iron, oops, I just made a blurch. Okay, strontium and iron chloride turns into iron and strontium chloride, which is true. Okay, oxidized and reduced. Okay, so strontium, so is strontium oxidized or reduced? It's going from 0, and in its compounds, we know that strontium is 2 plus, and we know that because of where it is on the periodic table. So we want oxidized, so that takes those answers, and it's going from 0 to 2 plus, that's answer A, because that's backwards. Number 17, magnesium plus oxygen turns into magnesium oxide. So what is happening to the magnesium? Okay, this is magnesium 0, and in its compound, magnesium is 2 plus, because you memorize our ions. So if I'm going to say magnesium turns into magnesium 2 plus, I'm going to have to put my electrons on the positive side, 2 electrons here. So then the oxidation number is going up, so that's oxidized, so I can get rid of reduced and reduced. And it is losing electrons. Electrons are on the right side, so it's answer C, losing electrons. And we know that it's oxidized, losing electrons is oxidation. Okay, for number 18, we say, okay, how many grams of HCl are needed to react with 3.25 grams of aluminum according to the balanced equation? Well, this is going to be a stoichiometry problem. So here's our given. Okay, and we're going to try, what are we trying? We're looking for grams of HCl. That's our desired. So I'm going to need some room. I'm going to change colors. And so I'm going to start off with 3.25 grams of aluminum. And I know that aluminum has a value of 27 grams per mole of aluminum. Now my heart of the problem says for every 2 moles of aluminum, and I'm trying to get to HCl, there are 6 moles of HCl. And I want grams of HCl, so 1 mole of HCl is 36.5 grams. So all the information is there, we just have to put it in the right place. And if you look at the actual posted answer for this test, you can see this calculation much, much better. So 3.25 divided by 27 times 6 divided by 2 times 36.5. When I do that, I get 13.18, which would be answer D, 13.2 grams of HCl. Okay, the last 4 multiple choice questions here are kind of longish. Okay, so here, number 19, how many grams of carbon are needed to react completely with 75.2 grams of silicon? Okay, so our given is the grams of SiO2, and what we're looking for is grams of carbon, so that's our desired. So this first number is our given, the other one's desired. So we need to set up a line equation for this. And I'm going to go ahead and try to do this down here at the bottom. So my given, 75.2 grams of SiO2, is going to go down here. Now what I want to do is change my SiO2 into moles. So I know SiO2 weighs 60. So I'll say 60 grams of SiO2 for 1 mole of SiO2. Then moles of SiO2. And I'm trying to get to moles of carbon. So from my balanced equation, there are 3 moles of carbon for every 1 mole of SiO2. I'm taking those 2 numbers. And I'm trying to get to grams of carbon, so I can say 1 mole of carbon is 12.0 grams of carbon. And when I work out this answer, Okay, so I have 75 times 3 times 12 divided by 60, and when I get all done, I get 45.12 grams of carbon. So 45, that's the answer C. Now when I get to 20, 20 is a little bit different. Okay, 20 is kind of a chart problem. So what is the final reaction mixture when 3.6 moles of hydrogen, 3.6 moles of oxygen are combined if the reaction goes to completion? So let's move down here and get some room. So for question 20, I'm going to start with my reaction. I'm going to need to make an ice box because that'll help me organize my information. Now what this says, I have 3.6 moles of hydrogen. I have 3.6 moles of oxygen, and that implies that I'm starting with 0 moles of my water. Now, of these two, we can kind of see we have equal amounts, but I'm using up my hydrogen twice as fast, so I'm going to use up all of my 3.6 moles here, because that's going to limit how much I can make. But I can say, well, 2 is to 1 as 3.6 is to 1.8, so I'm going to use up 1.8 moles of my oxygen. So this is my initial value, my change, and my ending value. And then finally what happens is, if I am making, using up 1.8 moles here, then I must be making some hot water. So 2 is to 2 as 3.6 is to 3.6. So I'm making 3.6 moles of water. And we can see what we're going to end up with. I'm going to have 0 moles of H2. I'm going to have 3.6 minus 1.8. I'm going to have 1.8 moles of oxygen. And I'll have 3.6 moles of my H2O. So I need an answer that says 0 H2, okay, 1.8 moles of O2, and 3.6. That looks like answer B. Okay, let's go up here to 21. Now we say consider the following reaction. If I have 5 moles of NO and 5 moles of O2 are mixed, which is the limiting reactant? Now I can actually calculate this out, but since I'm dealing with moles, I can kind of do this together. 5 moles and 5, I assume that means moles. So 5 moles of N2 and 5 NO and 5 moles of O2. Well, I'm going to use up my NO twice as fast as my O. So if I'm starting with equal amounts, I'm going to use up my NO first. So if I use up my NO first, that is my limiting reactant. So I don't even really need to do a calculation to do that, but I could just go ahead and run the reaction twice, do calculations, and take the smaller answer. Okay, last one here is number 22. When 5 grams of N2 are reacted with excess hydrogen by this reaction, then 2 grams of ammonia are produced. What's the percent yield? Okay, right away, if they say that's 2 grams is produced, that's my actual yield. And I want the percent yield, so I need to find the theoretical yield. And that is just going to be the answer to my problem. If I say I have 5 grams of nitrogen, and excess hydrogen means I have plenty of hydrogen, so don't worry about that. So if I start with 5 grams of nitrogen, how much ammonia can I make? So I'm going to move down here to give myself some room. Let's change colors. So now I'm on question 22. So I'm going to see if I have 5 grams of nitrogen, I want to find out how many grams of ammonia do I really get. So looking at my numbers here, nitrogen is 14.01, so 2 of them would be 28.02 grams for 1 mole. Okay, I'm not doing this right. Let me clean that up. Okay, 28.02 grams of nitrogen for 1 mole of nitrogen. Now from my balanced equation, it says for 1 mole of nitrogen, I can get 2 moles of ammonia. And I want to find out how many grams is that going to be. So 1 mole of ammonia, we're told in the problem, that's 17.03 grams of ammonia. So when I work this out, that's going to give me my actual theoretical value, my theoretical value. And when I do this, I get 6.0778 grams of ammonia. Too many significant figures. So now to finish the answer, the question is, what's the percent? So it said in the problem that the actual was 2 grams of ammonia, and I get 6.077 grams, okay, times 100%. And if I just round off, 2 over 6, that's 1/3, so I need an answer like 33%. And look at there, there's the answer, 33%. So that's the multiple choice section, and I will do a separate tutorial for the problems.